So here we go. When we're taking a look at this here, we're on lesson 3. This is called this box and whisker plot. Anybody ever seen a box and whisker plot before? Right? Whether you have or haven't, that's not a big deal. But sometimes we call them box and whisker plots. Other times people might call them box plots on page 6 of the notes. So you might see those phrases just used interchangeably, right? We just know that they're the same thing. Why box and whisker? Well, just by looking here, doesn't it appear that it has some whiskers on the far left and far right? Okay? And maybe those boxes are in the middle. Now, what each of these really mean, bless you, what each of these really mean is they have some type of way that the information is laid out. All right? So when we're thinking about this, I want us to know about a couple of different words that we may not have been familiar with prior to actually seeing some ideas here. One of the things I want us to be familiar with is right here. This is what we call just the minimum, the point on the far left. Okay? So we're going to use the minimum to describe that. So if the point on the far left is the minimum, what would we call the one on the far right? Maximum, right? So those are two words that we want to use here for this. There is the minimum, and again on the far right is the maximum. When we are analyzed, this right here is called the median. You've heard median before. It's no different than what you've heard, right? Mean, median, mode, range, right? You've heard of those phrases before. You line them up. Median is in the middle. The first and third quartile, you can grab that, Marin, if you wouldn't mind. The first and third quartile is also shown on a box and whisker plot.
It's SFA week, so we pop popcorn for all teachers and staff.
Thank you. Very appreciate that. So when we're looking at this here, we know that these are the 5, what we call a 5-number summary for each point of this data right here. And also what I know is when I'm looking at this, a box and whisker plot divides things in 25% regions. Each section of the box and whisker plot is divided into a 25% format. That's why they call it quartiles, right? Quartiles just like quarters in a dollar, quartiles like quarters in an hour, quartiles like some sporting events like basketball or football that are broken into 4 equal sections. Okay? So I know that 25% of the data is in each one of those sections there. Now, when we look at a box plot, we'll see it on a number line, right? If you don't see it on a number line, there's a good distinction that you probably see some numbers associated with that. All right? So here it is. It's asking to find the median here. Right? That's just the middle number. KJ, any thought about what number the median would be at for this box and whisker plot? 59. Now let's check it out here. He said 59. One thing we really want to be careful of is understanding what is the scale factor, right? He's looking at this value right here. Median means the middle. If we're looking down here below, what does it look like each of the tick marks is represented by? Is it counted by 1s? Is it counted by 5s? Carson's right. It's actually counting by 4s here, right? So, that means that this is 44. 48, 52, 56. So it's not 58, but it's 56, right? So just be mindful when you're looking here at it, you've got to be mindful about what it is counting by. Okay? Now, we know the answer for the median is 56. Here's my question. We could go through hundreds of examples, but this time it just asks us one thing. What if I also asked for the min and the max? Just adding more questions to this problem here. Allie, F, pick one of them, min or max, and tell me what number it would be. Min would be 20. Perfect. What about the max?
Max is 92.
How did we come up with that?
Look, I count by 4.
Sure.
84, 88, 92.
Yeah, there it is, right? So if we're just looking here, we're just counting by 4s. If it's easier for you students, take this line right here and actually extend it down so you see exactly where it goes, right? 92. Very nice. Let's ask ourselves a couple other pieces of information. We have 4 other things I want to know. What is, and this is the abbreviation for it, what is the first quartile? Notice how I wrote that right there. What is the first quartile?
It's like 36.
Right, we're just looking at the box here for that.
Q2.
We could count it up, right? But it looks like it is 36. Caleb, what about quartile 3?
8.
Okay, again, quartile 1 is right here. Quartile 3, yes, is 80. Now, when we go through this phrase of mean, median, mode, and range, Sam, do you recall what the range actually meant to do with that? How to find the range of a certain data set? Allie? Sure. Now let me analyze that. That is not what the range is, but it might be hard to add individual numbers here, right? Just because I'm not sure how many numbers are there. The range is when we use, Isaac, any thoughts? Yeah. Well, hang tight with us then, please. The range is when we take the highest and subtract the lowest from it, right? So, Sam, right here, what 2 numbers am I subtracting? What is 92 minus 20? 72. Right? So maybe that's just a quick refresher of what it is. But this last one, this is one that you may not have seen. Instead of just talking about the range, what if I said it's an interquartile range? So what do you think, or what 2 numbers do you think I'd have to subtract, because it does say range? What 2 numbers would I have to subtract for an interquartile range? Okay, so in this case here, what 2 specific numbers would that be? Because we knew this one was just the maximum minus the minimum.
80 minus 36.
That's right. We're going to take quartile 3 and subtract it from quartile 1. So Sydney, you said it. 83 minus 36. What would that be, Sydney? Okay, 44, right. Again, we could use a calculator as needed, right? But these are the 7 things that I want you to know just by looking at a chart like this, what is happening in here. Now, I will say this. You might run across this phrase right here, a 5-number summary. The 5-number summary for this right here is 20, 36, 56, 80, and 92.
Do I need to put this in?
If I'm writing it down, it might be a good idea. When you're looking here, students, This is the first number in the 5-number summary is always the minimum. The last number is always the maximum. This is the median, and this is quartile 3 and quartile 1 respectively. Right? So when you're looking at that here, be mindful that notice the 20 and the 92 are the very ends of it, right? 36 and 80, the ends of the boxes. 56 is in the middle. All right. I want you students on the next page to take a look at a problem, and I'm going to ask you to do those 7 type of things. So on this next page here, I want you, for example 2, please, to find in no particular order the min, the max, quartile 1, quartile 3, the median, the range, and the interquartile range. Just by looking at the number line right here, how is it counting? Every tick mark is represented of... Okay? Sure. Take a look at this, students. Try this one here on your own. All right, students. When we're taking a look here, did you get these 7 answers? Hopefully so, right? If so, we're on a good track for what this is. I want to skip the next example, example 3. I'll have this one uploaded on the notes page as needed, but we'll come back to that here in just a little bit. Example 4. The box plot below represents some of the data set. What percentage of the data are between 36, so again 36 is right here, and 48? What percentage of the data is between those 2 numbers?
Divide 36 and 48, and I got 66%.
Not 66%.
67?
Think about again how we talked about how this box and whisker plot is always broken up. We said it's a quartile, right? So how many even sections are there in a quartile? 4. So that means this section is 25% of the data. Same with this section right here, 25%. 25% on the last part of the box and the last part of the whisker. So Brooklyn, what percent of the data is between these 2 numbers? Just 25%, right?
Oh.
I could ask myself a different question. What percent of the data, Ryan Mitchell, is 36 or higher? What percent of the data is 36 or higher? 75%, right? I could ask it this way, Kenzie. I guess I'm not going to write this one down. But what percent of the data is 56 or less? What percent of the data is 56 or less?
50.
Where's 56 at? I guess that's the question, right, Kenzie?
Well, 56 is on...
Hold on just a second, Stephen. Give us a second here. Kenzie, where's 56 at? Okay. So, if we're counting here, it looks like, what is that? 2, 4... Oh, you know what? Can I amend what I said? My apologies. I meant to say, how many is... What percent of the data is 58 or less? My apologies. What percent of the data is 58 or less? It would be 100%, right? Because students isn't right here, and I apologize, Kinsey, for saying that incorrectly. Isn't right there 58, which is the maximum of this data set. So 100% of the data is at 58 or less. Okay? So that's a good introduction to box plots, right? If you decide to go to QR and stats, if you, and I believe anybody in here could do it, decide to go to AP stats, you get into a lot more of this idea right here, right? Let's take a look here at the next one. Example 5. Let's draw our own box and whisker plot given the following information. Mrs. Reardon gives a test over box and whisker plots. The minimum score was 42%, right? So if I'm thinking about my 5-number summary, I have a minimum, quartile 1, median, quartile 3, and a maximum. It says the minimum score was at 42%. The maximum score was at 100. The median was 84%. And the interquartile range was at 20%. So maybe, students, I could make it up like 90 and 70 right here. Would you agree that that would be an interquartile range of 20%? Well, it looks like right here, and maybe your spacing is not perfect, which is fine. But if I think about each of those numbers, the quartiles make up the box right here, with the median between them. And here are my whiskers on the far left and far right. Now, one thing I should probably do is, because I don't have it on a number line, I should probably just label them like that's 42, 70, 84, 90, and 100.
The max is 100?
The max score was 100%. So using these 5-number summary to actually create a box and whisker plot too. Let's take a look here at the next idea, histograms. When you flip the page here, you'll notice that, oh, these are graphs where we've seen like a long time ago, right, in math class? Sure, go ahead.
Why isn't 90 and 70? Why can't it be like 70 and 50?
Well, here's why it can be 70 and 50. I agree that it doesn't have to be exactly 90 and 70, okay? It can't be 70 and 50 because see how it wouldn't fit into that number summary right there? It would have to be a number between here, right? Maybe I said 94, and then this would be 74 then, right? So to your point, it doesn't have to be exactly what I said, but it does kind of have to fit within a certain range of values as well. If the way that this problem is worded, yes. But you might see a different one where it tells you.
But in that problem, it says
Yeah. All right. When we're talking about these pictures, we're going to use these histograms, right, to really kind of be reminded about what these actual values were, right, or what these definitions were. Now, we did already talk a little bit about a range. Isn't the range just the maximum minus the minimum? So this histogram, students, talks about the amount of siblings that students have in a class, right? So if I went around, I'll start, I would say, hey, I got one sibling, right? Carson, he could fill in the gaps as well, right? We could just keep going around. Excuse me, and we could record this in a table. The maximum amount of siblings that a student in this classroom has? No?
2.
The biggest number of siblings right here? Noah? What's the least amount of siblings that a student would have? 0, right? And so that kind of like, we think about that and that makes sense. There's obviously students that are only child, and then there's some students that have a lot of siblings, right? So if I'm finding the range, Noah, what two numbers am I subtracting then? Is 5 minus 0 is 5, right? I could find the mode. Carter, remember what the mode meant from previous years? The mode. Yeah, number that happens the most. So if I were to go and ask each of these people, what is the most amount of, let me think of how to say this grammatically correct. What is the number that I would hear the most often from students? 2, right? So just the number, bless you.
Thanks, Mr. Stinger.
Number that occurs the most. And, Mitchell, you said it. It's a deuce. The median. Remember we had to list all the numbers and see which one was in the middle, right? If you recall, you might see a list, cross them off from the beginning, cross them off from the end, correct? Beginning, end, beginning, end, beginning, end. Well, let's do it. Here it is, students. If I just make a list of all entries here, this is not the only way to do it, but I want to try to make a connection here. Don't I have 4 zeros? Don't I have number 1? Don't I have 7 2s? 3 3s? 2 4s? And 4 5s. So we got to cross it off, right? It definitely looks like I could cross 4 of them off and definitely not get to the middle, right? Could I cross, 3 more off from each side? Let's try it. 1 2 3. 1 2 3. Off. 1 2. 1 2. Looks like we can cross one more, and then there it is. The median is when ordered from least to greatest. It's the middle number. Only when it's ordered from least to greatest. In this case, it is 2. Now, Carter, you were saying that you did remember something about the mean. How do you find the mean here?
You add all the numbers and then you divide them by how many numbers you added.
Yeah, and now that's kind of what you were describing. I know we said the wrong word, but that's kind of what you were going after earlier, right? So let's add them up, right? Zeros. Those are nice numbers to add. So that's 1 plus 2, so 3, 5, 7, 9, 11, 13, 15, 18, 21, 24, 28, 32, 37, 42, 47, 52. Right? So if I add them all together, I get 52. How many am I dividing by?
How many numbers there are.
Which is how many? How many numbers did I just add together?
21 numbers.
52 divided by 21. Do we think that's a job for the calculator?
Yeah.
I think so, right?
I got 2.48.
2.48. Let's check it out. Let's see here. Where is a handy dandy calculator? I got 52 divided by, did we say 21? I got 2.5.
I run it to the nearest hundredth, but I'll trust it. 2.5.
Now be careful, because if you are getting a decimal, you will want to make sure to round exactly to where the directions are asking for. Okay? So keep that in mind, students. Let's look at another histogram here. Actually, we didn't even answer the questions. Let's do that first. How many students, Maya, have less than 3 siblings there? 12. Let's count it up, right? We said that, hey, there's 4, there's 1, and yeah, 12. Very nice. Damien, what's the most common number of siblings for the students in the class? 2 sibs. Right? 2 sibs. Now, be mindful. Obviously, Maya answered this correctly here, but don't count the 3s. It says, can you just set it down then?
Yeah.
Since you've been on it for the past couple minutes. Right here, be careful. It's not saying 3 or less, but it's saying less than 3. Okay? Let's look at the next histogram and kind of analyze what we have here. A teacher put all the quiz scores up on a representation right here. Which interval does the median test scores fall into?
70 to 79?
Steven, how'd you come up with it?
Wait, I didn't look at the median right, sorry.
Okay. If you were V going to look at this problem, how would you determine what the median is for this problem? How do you find the median of just any data set? Yeah. So how many 40 to 49s would I have? So I could write it down like this, right? Now this might seem a little bit tedious, so what I'm really interested to know is, anybody have a different suggestion than writing down 40 to 49 6 times? Caleb?
You could probably just put like the 4,
Sure.
5.
Okay, I see what you're saying. You're just talking about just making it a little bit shorter, right? So say, hey, all of these are really 40s, right? So I'm just going to use a 4 for that. Sure. Yeah, absolutely. Now, it's still kind of making a list of a whole bunch of numbers, though, right? Anybody have a different way of doing this without making a list? Allie?
Using exponents to do like 40 to 49 to 6.
Okay. So how do exponents affect that, then? You're saying use exponents to show it to the 6th? Now, that would just be, it's not to the 6th power, it just means that there's 6 of the 40 to 49, excuse me. Carter?
What are you supposed to subtract the 2 closest middle ones?
Why so? Yeah, but I don't even know where the median exists. Let's start by doing this. How many entries are in the 40 to 49 range? How many entries are in the 50 to 59 range? How many entries are in the 60 range? What about the next one? Sure, and keep going. Followed by? Students, if I analyze this chart, couldn't I see that if I cross 9 off on this side, couldn't I cross 9 off on the right side as well? So where is the median going to be? In the 70s, right? So instead of writing down all the numbers, maybe use the chart to determine what interval that might actually fall into. Which then begs the question, what do we think here, June, is the lowest possible score?
40 to 49.
Yeah, what is the lowest? You just told me 10 numbers. 40, 41, 42.
Oh, 40, sorry.
40, right? Yeah, the lowest possible score was just a 40 right there. Okay?